Hi everyone, welcome to JSET classes. In today's video, we are going to discuss the previous year question papers of NEET Physics. Today we are going to discuss the chapter 1, units and measurements, and today's topic of discussion is errors in measurement. Basically, this video is divided into two parts. The first part is a summary of the theory section, and the second part is the previous year questions. If you are well aware of the theory section, you can skip the first part and directly go to the second part. So let us begin. Measurement is the foundation of all experimental science and technology. In science, we do a lot of measurements. In daily life also, we have to take measurements. How we take measurements? We take measurements with the help of measuring instruments. While taking measurements using measuring instruments, there is always a possibility of error. So what error tells you is that the deviation from the true value. So basically error is true value minus measured value. You are studying about errors in measurements just to make you aware that errors always may happen while we take measurements. As future doctors, while diagnosing patients and analyzing their lab reports, you should always keep this point in your mind. Errors are of two types. The first one is systematic error and the second one is random error. So let us look at what a systematic error is. Systematic errors always tend to be in one direction. That is, it can either be positive or be negative. Systematic errors may not cause much trouble to us because the source of systematic error is known. Also, we know why a systematic error happens. As you know, there are three major components for an experiment. The first one is the instrument that we use to take the measurement. The second one is the experimental technique or procedure that we use. And the third one is the person who takes the measurement. Likewise, there are three types of systematic errors. The first one is due to instrumental error, and the second one is due to the imperfection in experimental technique or procedure, and the third one is due to personal error. And how can we minimize these systematic errors? The systematic errors can be minimized by improving the experimental technique or by selecting a better instrument or by removing the personal bias, that is giving more training to the person who takes the measurement so that he take the measurement in the correct procedure or technique or without causing any errors. But the other error we have is random error. The problem with random error is the source of random error is not known, and it also occurs irregularly. And random errors vary in size and sign. These occur due to unpredictable things, and such as the fluctuations in temperature, the fluctuations in voltage, mechanical vibrations are also all causes of these random errors. So source of random error is unknown, so it cannot be minimized like systematic errors. So how can we minimize this random errors? There is a method for it. We have to repeat the experiment several times and we have to take the arithmetic mean of all the observations. And thus we can minimize random errors. Let A1, A2, A3, etc. up to n be the measured values in an experiment. Then the true value or the mean value of A is given as A1 plus A2 plus etc. up to n divided by n. That is the arithmetic mean of all the measurements. Then we take this value obtained here or the mean value as the true value of A. In order to find out the errors in each of the measurements, for example, to find out the error happened in the first measurement, we denote the error happened in each measurements with the delta symbol. That is, delta A1 is equal to A1 minus A, where A is the true value of the measurement. Then by subtracting these two, we will get the error in A1. Similarly, the error in A2 is equal to A2 minus A, and so on. For the nth measurement, the error in n is equal to n minus A. I hope you understood that. Then we have the absolute error in measurement. By subtracting the measured value from the true value, we get the error. This error can be either be positive or negative. In order to find out the magnitude of error, we take the absolute error in the measurement. The absolute error can be taken by taking the modulus of that difference. For example, the absolute error in the first measured value, delta A1, the whole modulus is equal to A1 minus A, the whole modulus. By taking the modulus, we get the magnitude of the error. And similarly, for all the measurements, we will find out the absolute error in measurements. Remember, the absolute error represents the magnitude of error. Then similarly, for the mean value, we will find the mean absolute error in A. The mean absolute error in A is the mean values of all the absolute errors. That is delta A1 plus, delta A2 plus, etc. up to delta n divided by n. And thus we get the mean absolute error in A. The mean value, from the mean value, we take the difference and we get the error. Then we have absolute error, then the mean absolute error. This absolute error and mean absolute error shows how much error is there in a quantity. So it does not shows how much accurate is our measurement. In order to find out how much accurate is our measurement, we take the two quantities known as the relative error and the percentage error. The relative error can be obtained by taking the ratio of mean absolute error by the true value or the mean value of the measured quantity. By multiplying this into 100, that is relative error into 100, we will get the percentage error in the measurement. For example, I will tell you an example. If we have the true value of a quantity as 10, then we did a measurement and we get the measured value as 5. Then the error here is 10 minus 5 or 5 minus 10. Then the magnitude of error is 5. Then you can say that the error occurred is 5. Then the relative error here is equal to, that is the absolute error divided by true value, that is almost about 0.5. If you convert this into percentage error, we will get 0.5 into 100, that is equal to 50%. So the absolute error tells how much is the quantity or the magnitude of error, and the relative error and the percentage error tells how much accurate is our measurement. So I hope you have understood how to calculate error in a measurement and to find out how much accurate is the measurement. So now suppose here we have a rectangle, and the rectangle is having a breadth B and is having a length L. To find out the area of the rectangle, we have area is equal to length into breadth. Simple, right? But while measuring the value of the length, we get the measured value of the length as L plus or minus delta L. Why there is a plus or minus? Because we know that the random error can be more than the true value or it can be less than the true value. Also, the measured value of breadth, we will get it as B plus or minus delta B. Now you understood that there is an error in the length and breadth measurements. Then using this length and breadth, you calculated the area. So whether there will be some error in area also, right? So how to calculate the error that occurred in this area measurement? That is, now we are going to study how errors propagate or how errors combine and give errors in our results. First, we will learn how error propagate when we do the sum and difference. Suppose we have a quantity called Z and it is obtained by the sum of two physical quantities A and B. And we know when we measure the values of A, we get the measured value of A as A plus or minus delta A and the measured value of B as B plus or minus delta B. Then there will be some error in the measured value of Z. That measured value of Z can be calculated as delta Z is equal to delta A plus delta B. Similarly, there is another quantity, so let it be Z1 is equal to, that is obtained by the difference of two physical quantities A and B. So the error in Z1 is equal to the error in A plus the error in B. So you have to remember that for addition and subtraction, the error always propagate in the same manner. This error in Z here is equal to the addition or the sum of the errors in physical quantities A and B. Similarly, the error in Z1 is also equal to the sum of errors in physical quantities A and B. So let us now look how the errors propagate in product and quotient, or in multiplication and division. So there is a physical quantity called Z2 and it is equal to A into B. We know that the measured values of A is A plus or minus delta A and measured value of B is B plus or minus delta B. Therefore, the relative error in Z2 is equal to, that is relative error in Z2 means delta Z2 divided by Z2 is equal to delta A by A plus delta B divided by B. And the error in Z2 can be obtained as error in Z2 is equal to Z2 multiplied by relative error in A plus relative error of B. Similarly, for another quantity called Z3, that is obtained by dividing A and B, we can write the relative error in Z3, that is delta Z3 by Z3 is equal to delta A by A plus delta B by B. That is the relative error in A and the relative error in B. Therefore, the error in Z3 can be obtained as Z3 multiplied by delta A by A plus delta B by B. I hope you have understood how to calculate the error in addition, subtraction, and multiplication and division. So let us check how the error propagate when there is a quantity raised to a power. Suppose we have another physical quantity called Z4 and it is obtained by a to the power n. Therefore, the relative error in Z4, that is equal to delta Z4 by Z4, that is equal to n into delta A by A. Okay. Now I have a question for you. If there is another physical quantity Z5 and the D is equal to, let it be A raised to C, then B raised to D divided by C raised to A, then D raised to B. Then how we can calculate the relative error in Z5? So let us check. Relative error in Z5, delta Z5 by Z5 is equal to C multiplied by delta A by A plus D multiplied by delta B by B plus A multiplied by delta C by C plus B multiplied by delta D by D. To calculate the error, we can multiply Z5 to this side. So, I hope you have understood how the errors propagate in all the different operations. To find the percentage error, we can multiply all the terms into 100 and we can get the percentage error in the quantities. So I hope you have understood the theory well. Now we are going to attempt the previous year questions that is asked in NEET from this error in measurement section. My advice to you is that you have to attempt these questions first by yourself by pausing the video. Then you can check the solution. So let us begin. The first question is, in an experiment, the percentage error occurred in measurement of physical quantity A, B, C, and D are given as 1%, 2%, 3%, and 4% respectively. Then we have to find the maximum percentage error in the measurement X, where X is given as X is equal to A raised to 2, B raised to 1 by 2, C raised to 1 by 3, and D raised to 3. So we have to calculate the maximum percentage error in X. So pause the video and try to do it yourself. It's a very simple question. I hope you have attempted the question and you got the answer. So let's check the solution. So the percentage error in X, that is given by the relative error in X multiplied by 100 is equal to, and we know that when a quantity is raised to a power, we can write it as 2 multiplied by the relative error in A. We need the percentage error, so we have to multiply it by 100 plus 1 by 2 into delta B by B multiplied by 100 plus, why we took plus here? Some of students have doubt that we should keep minus when we deal with quantities in the denominator. No, because in error propagation, when quotient is there, the relative error is taken as the sum of the relative errors. So we have to take it as plus. 1 by 3 into the percentage error in C plus 3 into the percentage error in D. In our question, the percentage error for A, B, C and D is given as 1%, 2%, 3% and 4%. So we can simply substitute here, that is for delta A by A into 100, that is the percentage error in A, that is 1 plus 1 by 2 into delta B by B into 100, that is the percentage error in B, plus 1 by 3 into percentage error in C, that is 3%. We can write it as 3 plus 3 into percentage error in D, that is 4. So we have 2 into 1 is 2, 1 by 2 into 2 is 1, 1 by 3 into 3 is 1, and 3 into 4 is 12. And 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 12 is 16. So the correct answer here is 16%. So we get option C. So let's look at the second question. In an experiment, 4 quantities A, B, C and D are measured with percentage error 1%, 2%, 3%, 4% respectively. The quantity P is calculated as follows. This is the same pattern question. I think you can attempt this also. So the percentage error is given for each of the quantities. You have to find out the percentage error in P. The percentage error in P is equal to delta P by P multiplied by 100 is equal to 3 into delta A by A into 100 plus 2 into delta B by P into 100 plus delta C by C into 100 plus delta D by D into 100. And the percentage error in delta A by A is given as 1 plus 2 into percentage error in B is given as 2 plus percentage error in C is given as 3 plus the percentage error in D, it is given as 4. Therefore we get 3 plus 4 plus 3 plus 4. This 3 plus 4 is 7, 7 plus 3 is 10, and 10 plus 4 is 14%. So 14% is the answer. So let us look at the next question. A student measures the distance traversed in free fall of a body initially at rest in a given time. He uses this data to estimate g, that is the acceleration due to gravity. If the maximum percentage error in the measurement of distance and time are E1 and E2 respectively, then the percentage error in the estimation of g is. So the percentage error in distance is given as E1 and the percentage error in time, measurement of time, is given as E2. So let us analyze the question in a little bit detail. So remember that the body is in a free fall. So let us draw a diagram and analyze the question. So body is in a free fall. The student measures this distance and the time for the free fall. Okay. So let the distance that the body go down is d and the time it took be t. So what's the question? A maximum percentage error, then the percentage error in estimation of g. We have to find the percentage error in estimation in the acceleration due to gravity. You know the equation of motion is s is equal to ut plus half at square. Here the distance the body followed is d. And the initial value, the body is initially at rest, right? The body is initially at rest So we can take the initial velocity u as 0. So 0 plus, then we have half, the acceleration is g, then we have time is t, therefore t square. Then we can write the equation of g as 2d divided by t square. And now in the question it is given that the percentage error in d is even and the maximum percentage error in the measurement of time is it. Let's check as d is even and t is it. So we have to find the percentage error for the estimation of g. By using the theory we have learned for the combination of errors, we can write delta g by g into 100, that is the percentage error in g is equal to 2. This 2 is a constant, right? So therefore it has no change. Or therefore we can neglect it. Or if you write delta 2 by 2, it will get 0. And we have delta d by d plus, here t is raised to power, so for 2 into delta t by t. So we have to multiply these two by 100. And we get the percentage error, that is the delta d by d into 100 plus 2 into delta t by t into 100. And this quantity here it is given as E1. Therefore E1 plus 2 into E2. So for the option is delta g by g into 100, that is, or the percentage error in g is equal to E1 plus 2E2. So let's check the options. E1 plus 2E2. So option B is the correct answer. So let's go to the next question. The error in the measurement of radius of a sphere is 2%, then the error in the determination of volume of the sphere will be. You know that the volume equation for volume of a sphere is 4 by 3 pi r cube. The V is the volume and r is the radius of the sphere. Then we have to find out the error in the determination of volume of the sphere. And percentage error in the measurement of radius is given as 2%. Okay. Therefore, the percentage error in volume is equal to delta V by V into 100. This 4 by 3 and pi is our constant. So we need not have to bother about this. We have 3 into delta R by R into 100. And we get 3 into this percentage error in radius, it is given as 2%, right? Therefore we can write 2 and we will get the percentage error in the volume as 6%. So option D is the correct answer. So we can move on to the next question. The density of a cube is measured by measuring its mass and length of its sides. If the maximum error in the measurement of mass and length are 3% and 2% respectively, then the maximum error in the measurement of density would be. We know that the density is given as density is equal to mass by volume. Or in other words, we can write it as mass divided by length, the whole cube. Therefore, the percentage error, we have to find out the maximum error in the measurement of density. The options are also given in percentage, and we are given the things in percentage, that is the percentage of mass and percentage of length also is in percentage. Therefore, the density, the percentage error in density is equal to delta m by m into 100 plus 3 into delta L by L into 100. And percentage error for mass is given as 3, and for the length it is given as 2. Therefore, it is 2. Therefore, 3 plus 6, that is equal to 9 percentage. So option D is the correct answer. The percentage error in the measurement of mass and speed are 2% and 3% respectively. Then the error in the estimation of kinetic energy obtained by measuring mass and speed will be. We know that the kinetic energy can be written as, the equation for kinetic energy is equal to half mv square. So for the percentage error in kinetic energy, that is delta Ke by Ke into 100 is equal to half. We need not have to consider this half because it is a constant. We have delta m by m into 100 plus 2 into delta v by v into 100. This delta m by m, that is the percentage in mass, it is given as 2%. Then we have the percentage error in velocity, it is given as 3%, therefore 3. Therefore 2 plus 6, that is 8%. 8% will be the answer. A certain body weighs 22.42 gram and has a measured volume of 4.7 cc, that is cubic centimeters. So for the original weight of the body is given as, that is the true value is given as 22.42 gram, and its volume is given as 4.7 cubic centimeters, that is equal to 4.7 centimeter cube. The possible error in the measurement of mass and volume are, therefore the error in weight or mass, it is given as 0.01 gram, and the possible error in volume is equal to 0.1 centimeter cube. So we have to find the maximum error in the density. Therefore, the maximum error in density, that is equal to delta rho by rho, that is rho is density into 100, because all the options are given in percentage, so we need the answer in percentage, so we have to multiply it by 100, is equal to, then we know that density is equal to mass by volume, or in other words weight by volume. So we have m and v, therefore it has, we denote it as w, delta w by w, weight into 100 plus volume, percentage of volume, that is delta v by v into 100. And by substituting the values we get 0.01 divided by original measurement is 22.42 into 100 plus, and the volume we have the error as 0.1, and the original value of volume is 4.7 into 100. So we'll get this 0.01 is actually, it is 1 by 100, and I take it as 1 by 100, and I will do a little bit of approximation here, that is 22 into 100 plus this 0.1 is 1 by 10, and I take a little bit of approximation, that is 5 into 100. Therefore the 10 and 10 cancels 2, and 100 and 100 cancels, and I will get 2 plus 1 by 22. We will get is, it is equal to 2 plus something is equal to 0.0. We'll get 4, then 488, 12, 120, then we have 5, therefore it is equal to 0.45. Or approximately we can take it as 2%. I think you can see it here. On final the result is 2%. So that's the answer. I hope you have understood the concepts very well, and actually these in for the NEET from errors of measurement they have asked questions of very less difficulty, but you have to expect questions from the combination of errors and for the relative error, percentage error, absolute error. From there also they can ask questions, so you have to read those portions also, prepare well. So that's all about this session, and study well and continue your studies. All the best for your NEET preparation. Please do also, please do support my channel by subscribing to it and also share it with your friends. So thank you. See you in next session with another topic of previous year NEET questions.